Hello everyone. So in this part of my video, I'm going to discuss about the structure of fructose and its properties, that is physical and chemical properties of fructose. So this is the straight chain structure of fructose, and here as you can see it has 6 carbon atoms, and this ketone group is the functional group. Then it has 5 hydroxyl group. So since it has 3 asymmetric carbon atoms, that is carbon 3, carbon 4 and carbon 5, these 3 are asymmetric carbon atoms, so it has 2 to the power 3, that is 8 isomers. And the optical isomers for fructose are D-fructose and L-fructose. D stands for dextrorotatory and L for levorotatory. So D-fructose, it rotates the plane polarized light into right hand side or in clockwise direction, and L-fructose or levorotatory fructose rotates the plane polarized light into left hand side or in anti-clockwise direction. And these two structures are optical isomers to each other, and they are mirror images of each other. Now by seeing the structure of this molecule, we can say whether which molecule is D form and which molecule is L form. Now here you can see that carbon 5 is the most distant asymmetric carbon atom from the functional group, that is from ketone group, which is carbon number 2. So from carbon 2, carbon 5 is the most distant carbon, and which is the most distant asymmetric carbon. And at this carbon, OH group is on right hand side, so this structure will be D form, and in L form this OH group is on the left hand side. So by seeing the structure, we can differentiate between D form and L form. Now the ring structure of fructose. So the ring structure of fructose follows a similar pattern as that of glucose, but with a few exceptions, since it has a ketone group, and the ring closure occurs at carbon 2. So here a 5-membered ring is formed. The OH group on carbon 5 is converted to the ether linkage to close the ring with carbon 2. So this makes a 5-membered ring with 4 carbon atoms and 1 oxygen atom. So in the formation of this ring structure, the electrons on the oxygen on carbon 5 are used to bound carbon 2 to make an ether, and the hydrogen is transferred to carbonyl oxygen to make a new alcohol group. So in this hemiketal functional group, this anomeric carbon is the central carbon atom. So here you can see this is the hemiketal functional group, and this carbon 2, which is at the center of this hemiketal functional group, is the anomeric carbon atom. Now the cyclic structure of fructose has 2 forms, that is alpha and beta. The alpha is defined as the OH being on the opposite side of the ring as carbon 6, and in this ring the OH group is downward projection for the OH on C2, that is carbon number 2, and in beta position is defined as the OH group being on the same side of the ring as carbon 6, and here the OH group is upward for the carbon 2. Now here some physical properties of fructose. So fructose is the sweetest sugar of all the sugar molecules. It is soluble in water and sparingly soluble in ethanol and insoluble in ether. D-fructose, it is the natural sugar and it exhibits mutarotation, and the final value of specific rotation is 92 degree. Fructose is white crystalline solid with molecular formula C6H12O6, and melting point is 103 degrees centigrade, and its density is 169 gram per liter. Now, some physical properties of fructose are: fructose responds most of the usual properties of the ketonic and hydroxyl groups present. A very important property of the fructose is that although it has no aldehyde group, it reduces Fehling solution and Tollens reagent. And this reducing property of fructose is said to be due to the presence of an alpha hydroxy ketonic group, which is readily oxidized by Fehling solution and Tollens reagent. Fructose on treatment with hydrogen cyanide gives cyanohydrin, which on hydrolysis followed by reduction by hydroiodic acid and red phosphorus, it gives N-butyl methyl acetic acid, and the formation of this compound again indicates that the ketonic group present at the second position. Now here there are some reactions of fructose with some reagent. So fructose reacts with Mollis reagent and it gives purple ring at the junction of two liquids, and which indicates that fructose is a carbohydrate. Fructose also reacts with Benedict's reagent to give brick red precipitate, which indicates that fructose is a reducing carbohydrate. Again, fructose reacts with Barfoot's reagent to give a scanty red precipitate at the bottom of the test tube, which indicates that fructose is a reducing monosaccharide. Fructose reacts with Selivanov's reagent to give cherry red color, which indicates that fructose is a ketohexose sugar. Again, fructose forms osazone and it gives needle-shaped crystal. So, fructose, glucose and mannose, all these three monosaccharides, they form similar crystals. So, this is all about the chemical structure of fructose. So, the function and the sources of fructose will be discussed in the next part of my video. Thank you.